We haven't quite considered what happens when s equals to 1, r equals to 1, right? So number 6 is s equals to 1, r equals to 1. Let's say we are currently storing a 0 and this would be a 1. So what would be q plus and q prime plus? Let's see what happens. So r is 1, s is 1, q is 0, and q prime is 1. So this 1 goes all the way up here and you get a 0. This 0 goes all the way down here. So 1 nor 0 is a 0. This 0 goes all the way up, right? So this 0 comes all the way down here. So 1 nor 0 is a 0 again. This 0 is going to go up and you're going to settle at this point here. So your q plus will be a 0 and your q prime plus will also be a 0. So that's the number one violation. So your q plus will be a 0 and your q prime plus is a 0 again. Remember, I told you that in a latch, you're going to have two outputs, q and q prime, and both have to be complementary to each other. So this is going to violate that. Okay, it's still fine. Let's assume that it's still going to be stable though, right? Now let's see what happens when I set s equals to 0, r equals to 0, and you know that q equals to 0 and q prime is also equals to 0. So let's see what happens now. So here we are going to assume that both the NOR gates work at the same speed, right? So you have r equals to 0, s equals to 0, q equals to 0, and q prime is also equals to 0. Remember, both the NOR gates have the same speed. So this 0 goes here and this 0 goes here at the same time. The output of this is going to change to 1 and the output of this is also going to change to 1, right? So this one goes up here, this one goes down here. 1 nor 0 is a 0, and again 1 nor 0 is a 0. This 0 goes up here and this 0 goes down here, right? So 0 nor 0 is a 1, 0 nor 0 is a 1. So this circuit is going to oscillate between 0 and 1. So oscillates between 0 and 1. This is on the assumption that both the NOR gates are working at the same speed. If the upper NOR gate works at a faster speed, the Q is going to settle at 1 and Q prime is going to be at 0. And if the lower NOR gate is going to work faster than the upper NOR gate, Q prime would be a 1 and Q would be a 0. So in any of these three cases, you're not able to predict the value of Q, right? Because it's a physical component and you do not know which one behaves in what way or which one is going to work faster than the other. This is known as the race condition. So your Q plus will be 1, 0, 1, 0, and so on. And your Q prime plus will also be 0, 1, 0, 1, and so on. Or 1, 0, and so on. So this is unstable, which is why in an SR latch, we make sure that we never set the inputs S and R to 1 and 1. So this is going to be don't care and invalid. So make sure to never set S and R to 1 in an SR latch.